All right, well, now let's see how much of this I'm going to be able to get through. But we got the review for your test 2. So the test 2 has focus questions on it, and we want to focus on those that are identified in the announcements. So we look at first question number 4. Now, the way to do this to get ready for your test is by doing these questions that I'm doing with you over and over again until you've exhausted all these questions. Okay, that's how you're going to prepare for this test. Okay, so let's take a look at question number 4. Now, question number 4 says simplify the given radical expression without using a calculator. So what they're trying to have you do is take it without a calculator and break it down. For example, 175, we know that 175 multiplies by, something multiplies 25 to get 175, right? Now, if you think about it closely, right, you can think about this as 25 cents and this is $1.75. And that means that there's 7 quarters in $1.75, or 7 times 25 is 175. That's just one way of thinking about it, right? Now, why did I target 25? Because 25 is a perfect square. And when you have a perfect square inside of a system like this, you can split it up into 2 parts. The square root of 25 times the square root of 7. And now this can be simplified to be obviously 5, because 5 times 5 is 25, and we know the square root of 25 is 5. So now, just as a single point of reference, I want to make sure that you understand that this could be rewritten as this, and that the index, because it's understood to be 2, could look like this. All right, so then we have this, and we know that anything over itself is 1, so we have 5 to the first power, which is equals to 5, and that's why it seems to be generating 5. But that's just another way of looking at it, rather than knowing for the fact that 25, the square root of 25 is 5. All right, so that's the answer we're looking for, and I'll go ahead and show you the answer that's there, and it's what I came up with, right? So the next question we're going to look at is number 7. All right, so question number 7 wants us to simplify this. So we have 169 over 4. Well, when we do it like this, we can also separate them into this. And when we have that, we have 13 over 2, because the square root of 169 is 13. The square root of 4 is 2. So that's our answer. All right, not a big deal. Now, number 8. Now, this is a cubic function. Okay, so that's, now you're going to see the value of the index. That's called an index. Now, 3 times 3 times 3 is 27, by the way. But then you have a negative 27. So that doesn't work. So you got to put a negative and see what happens. So negative times a negative is positive, and a positive times a negative is going to give you a negative 27. So that works. So this value here is equal to negative 3. And the way that variables work is very simple. You take the index and you divide it into the power of the variable. So you divide if it goes evenly, which is nice. This is 21, that's 7 times. 3 goes into 24 8 times. And 3 goes into 9 3 times. And there's our answer. I'm making this look ridiculously easy because, in a sense, it is, as long as you know the rules in which you engage on it. All right. Now, this one right here is all about using a calculator. Okay. So you have to use a calculator And if and this one is definitely going to be on the test, right? So this one's a freebie in my opinion. So I'm going to use my phone, which you're not allowed to use your phone, by the way. Okay. So square root of, and then it's 2.6 times, oops, I gotta go ahead. Oh yeah, times, oh yeah, okay, there it is. Times, and then they give you the value of what R represents, and that's going to be 630. So we put 630 in there and hit enter. So there's our answer. It wants us to round to what's down. It wants us to round down to the nearest whole number, so it's going to be 40 miles per hour. Okay. Sorry about the add thing there, but I'm using a free calculator, so that's what I'm going to get. Okay. All right. Now, this one is as easy as that. Okay. Just so you're aware of it. All right. So number 9, you don't even have to write down. All right. Number 12. Now, it wants us to evaluate 25 raised to the 1/2 power. Now, this is understanding of, well, do you understand that this really means the square root of 25? And we just did square root of 25 is 5. I mean, this one goes very fast, so this one's 5. All right. 13. Now, the way this works is they want to use the property of exponents. So whenever you're dividing, you subtract this from this. Now, 4/5 is larger than 1/6, by the way. That's important to recognize. Now, what we want to do is bring this to the top, and when we do, we subtract it from the 4/5. Now, we need a common denominator, and that would be 30. All right, so when we come up with 30 as our common denominator, we ask ourselves, well, 6 times 5 is 30, so 6 times 4 is 24. And then 5 times 6 is 30, so 5 times 1 is 5. And then you go ahead and subtract. Well, 5 taken away from 24 is 19. So our answer is going to be x to the 19 30th power. All right. And then it says it wants us to assume all bases are positive, use properties of exponents following. So we have our answer. That's hard to read, but it is exactly what I came up with. Okay. Just so you're aware, it's the same thing. Number 14. All right, it says using the properties, we have x to the 1/2 power times, and now I'm gonna make this a little bit bigger. I have to say, I'm having a hard time seeing that. Let's see here. It doesn't want to allow me to use the controller feature. It's 1/5. I was trying to make it bigger, but I'm not gonna. I don't know why. I would have to zoom in, and that's, I guess, the way I do it. I was hoping to use the functional keys, but it doesn't seem to want to work. Okay, there we go. All right. Trying to make it bigger for you all. If you can't read that now, there's a problem. All right. Now, I want to go ahead and recognize that these are the same bases. I'm going to go ahead and add my exponents together. Well, 10 is going to be my LCD. And I ask myself, well, 5 times 2 is 10. So 5 times 1 is 5. 2 times 5 is 10. So 2 times 1 is 2. Now I go ahead and add these together. I get x to the 7/10 power. All right. Now you can see that one. Now 15. Rewrite the expression in radical form. Now for 15, you got to be careful not to extend the radical. Now, what I mean by that is it's going to be only applied to the variable, not to the 7. So your answer is that way. Okay. Don't give it to the 7. Don't make 7 part of it. The only way 7 would be part of it if it was written like this. All right, that's the only way it would be written with a 7 inside of it. So that's why our answer is written this way. Now remember that the denominator is the index, the numerator is the power. Okay. #21. Simplify this. Well, since this is b to the third, all right, not b to the third, excuse me, b to the second, but this is an index of 3, we have to have 3 of one number. So 3 can't go into 2. So we're going to leave it as the cubic root of b to the second. But 64 is 4 times 4 times 4. And so that means we're just going to put 4 in the denominator and leave it with the radical in the numerator. So denominator and the numerator. Okay. #23. Now we're looking at the square root of 25x to the 9th, w to the 4th. Now remember, square root really means 2, right? So we can take the square root of 25. We can't divide 2 into 9. So what we do is change the x to be x times, or x to the 8th times x is still x to the 9th, right? So then you take 2, divide into 8, and that gives you x to the 4th. And then you're going to have w, 4 divided by 2 is 2. So w to the second. And then what's going to end up happening is you're going to leave this x inside the radical because it doesn't have a home. It's kind of alone. So the 2 can't go into 1, right? So we leave it alone. There's our answer. All right, with the whole radical and everything. All right. See, these aren't that bad. They're not that bad. 25. Again, this is square root. So we take the square root of 4, that's 2. 2 can go into 12 6 times. 2 can go into 8 4 times. And 2 can go into 6 3 times. It's just simple division. Look at the answer. I mean, this takes no time at all to do. As long as you know what you're doing, this should go very quickly. Now, right here, when we're looking at this kind of question, there's a couple approaches you can make towards it. First, you can go ahead and combine it as all one radical. And what that means is 2 goes into 50 25 times. And 9 taken away from 11 is 2. And now you've simplified it. What's the square root of 25? And how many times did 2 go into 2? And here's our answer. I may have been off the page. I apologize. $28. All right, so now we're looking at 2 radical 108 minus 3 radical 245 minus 2 radical 12 plus 1 times radical 5 is just simply radical 5. Now, when I'm looking at this, okay, I notice this being that 36 can go into this number, okay? Now, I mean, I see it as 36 because I know that it's going to be 4 times 9, by the way. So the idea is to take 36 and divide it into 109, okay? Or 108, excuse me. So you take 36 and divide it into that, and it gives you 3. All right, so you go ahead and see 36 times 3 is here. And then likewise, when we think about 245, we think, what could 245 divide by? So when we're looking at that, we could take 245 and divide it by 25, and it won't work, right? You can immediately take 245 and divide it by 5. Why I would do that is because it's divisible by 5. And when we do that, it's 49 times 5. All right, and 49 is a good one to divide by because it's a perfect square, 7 times 7. And then when we look at 12, 12 is 4 times 3, and that's the same thing as taking and bringing it out as 2, and I'll show you that in just a second. But now what we did was we cleaned this up a little bit to get our perfect squares to be identified. So the square root of 36 is 6, and then we're going to multiply that against the 2. So 6 times 2 is 12. Leave the 3 in. 7 times 3, because the square root of 49 is 7. 7 times 3 is 21. Radical 5. And then 2, because 4 times, or radical 4 is 2. 2 times 2 is 4. And leave the 3 in. And then you have just radical 5. Now with radicals, they have to be the same in order to add them together. So these two are going to add together, and these two are going to add together. So then what is 12 minus 4 is 8. Radical 3. And then negative 21, add 1, because that's what's understood to be here, and that's why they put it in the problem. So that's going to give you negative 20. Radical 5. And there's nothing else you could do with the radicals. You leave them alone. And there's our answer. Okay? So this one is about cleaning up your radicals and simplifying. Always looking for your perfect squares. Literally, if you have to have in the time, not during the test, but during the time you're learning this and stuff, you need to go ahead and identify all your perfect squares and do so. And that's what you're going to constantly be dividing things into this. Even if you didn't know 36 would go into this, you can see that 9 times 12 is 108. And then you know that 12 is 4 times 3. And so even if you didn't know 36 can go into it, just by the mere fact that this works, you can look at 9 times 4 and see that it's 36, and you know the square root of 36 All right, so there's alternative ways of getting to there. But you can use your calculator, right? You can take 108 and divide it by your perfect squares. That's why it kind of frustrates me that students get stuck on this. Like this one, we could have chose to divide it by like I said, 25 and see that it doesn't work. It's 9.8 or something like that. And then, but we're going to go ahead and divide it by 5 because 5 can go into anything ending in 5, and it resulted a 49, which we automatically see that it is a perfect square. So handle this with that directive, like in terms of trying to simplify these things. Number 30. Now, when we're looking at this, we need to get these cleaned up. We can see this is 4 times 2. We can see this is 9 times 2. And then we can see these are perfect squares. So then square root of 4 is 2. So 2 times 7 is 14. And leave 2x inside. Square root of 9 is 3. 3 times 2 is 9, or excuse me, 6. And then 2x. And then now these are both negatives. So we're going to add them together. So it's going to be negative 20 square root of 2x. Okay? And that's it. All right. Now, we're going to go ahead and try to start cleaning this up. So taking 96, we're going to try to go after our perfect squares. And 96, let's just say divided by 16, for example. All right, so taking 96 divided by 16 gives us 6. So taking and breaking it up, you get 16 times 6 is 96. And then 216. Divide 216 by 27. But wait a second. Let me think about that further. Okay, so take 216 divided by 36. Let me go a little further than that. Yep. So 36 goes into that 6 times. So 36 times 6 is 216, by the way. That's a perfect cube. That's what made me think about that. Although 8 can go in, 27 could go into it. It's better if we did 36. All right, now 150. We're going to obviously see that that is 6 quarters. So now we have this. Okay. So the square root of 16 is 4, so we're going to get 4 times 2 is 8. And then the square root of z squared is going to give us z. And then we're left with 6. Now, we have a 3z, and the 36 is going to become a 6. So 6 times 3 is 18. Z radical 6. And then 25 is going to become 5. 5 times 4 is 20. And then z squared is z. And then you have the square root of 6. And now all these must match in order to add the coefficients of them. So they do. So now it's negative 20 added to 18 gives us negative 2. Negative 2 added to 8 gives us 6. So we have 6z radical 6. So cleaning up, simplifying it, and then bringing it together. Okay. Now we have multiplication. A little bit. Okay, get a little bit off. All right. Here we have this. Now, when we're multiplying radicals and we're squaring it, remember, we could do this perfect square formula. Okay. We can use that perfect square formula. A squared is going to give us 3. Double the value of them multiplied together. And then go ahead and do b squared, which is 7. Add these two components together. 7 plus 3 is 10. Plus the 2 radical 21, and you're done. Okay, this formula is critical for you throughout. You got to study it. If you don't remember it, you got to study it. I mean, I don't want to hear you can't do it. It's just you got to commit things to memory. Just like it's helpful for your brain to remember these things. It's not about being smart, by the way. I can't stand that when people say that. That's a cop-out. It's about studying and being committed to things, right? Now 37. We're talking about the square root of 7 times negative 6 is going to give us negative 6 square root of 7. And then when the square root of 7 multiplies the square root of 7, that's going to give us plain old 7, because you're going to actually get square root of 49, which is a perfect square. So anytime a radical multiplies against itself, I always say take it out of the house. So 7 times 5 is 35. And so it is. We can write it this way, but it's probably more appropriate that we put the 35 over on this side. It's a lot easier to write it. So it'd be 35 minus 6 radical 7. That's in my own personal opinion, but you won't get it wrong if you put that, by the way. So here's your answer that I gave. But now rationalizing the denominator. Hope I'm not going too fast. I mean, the one thing about when people say, "Oh man, you're going too fast," I'm not making it hard. That's the thing, is that you're making it too complicated if you think I'm going too fast. I'm just giving simple facts. You know, I'm using my calculator just like you would. I mean, I'm doing it off the screen kind of thing. I'm not showing you I'm using a calculator. There's no sense in that. You can do the calculator thing as much as I can. But now when we look at this, okay, taking the square root of 169, we've seen that one before. The square root of 169 is 13. And so we're looking at just basically this. And in order to get this rationalized, we need the radical not to be in the denominator. So what we just do is just multiply both top and bottom by radical x. This will make the radicals go away, leaving us with x. Because remember what you get. This gives you radical x squared, and taking 2 divided into 2 gives you 1. And I always tell students, whenever you multiply anything by itself, it always just comes out of the house. I mean, that's just a simple thing. And then 13 times radical x. And that's your answer. So you're trying to get the x out of the denominator. That's all you're trying to do with this. That's rationalizing the denominator. All right, rationalizing the denominator here. I mean, this is a good representation of everything that's across the board here. All things studied in this section. So that 15 is in the radical. So now the thing is that we can't get this simplified at all like the way we did this. So we're just going to leave it, but we're going to break it up first into this. Okay, we're going to split it into 2 parts because then we are going to go ahead and multiply both top and bottom by radical 15. So that gives us 15. And then, of course, I don't know what 13 times 15 at the top of my head is. So 15 times 13 without any problem is 195. And then we're done. There's the answer. Okay, so denominator, or rationalized denominator, is not very complicated. You can see how fast I'm moving on them. Rationalizing this denominator. All right, you would just simply multiply both top and bottom by radical 2x. And guess what? We're already done. There you go. Done. It is ridiculous how easy this are. I mean, give me rationalizing denominator all day. I mean, this is the fastest. I mean, this one was way harder, right? This one was way harder than that. That took me a lot longer to do than this rationalizing did. All right. All right. Now we get into complex number systems. So question number 47 deals with complex numbers, because all you're doing is anytime you can't take the square root of any negative value, because there's no such number that multiplies against itself that equals that. So what you do is you understand that the square root of -1 is understood to be I. So anytime you see a negative value inside of a radical system, then just take it out as I. This is how fast you do it. Now, no more negative sign. Boom, that's an I. I just don't understand why that's so complicated. Just, you understand this, so then you understand this. And if you don't, you understand it now, okay? So this 50 we know is 25 times 2. So the answer is 5i times radical 2. And that's your answer. All right. Now, you'll see how I have it written. My way of writing this is better than the way they're writing it. The reason why we don't ever want to put the I in the back is sometimes, especially when we're writing, is that sometimes that could be misinterpreted, and that is a boo-boo. And since we are humans with human error, we look at this as a better way of writing the I. However, the thing is that you get into the concept of BI, and they always want to put the B in front of the I, so that's why they'll write it this way. All right? But there's no difference in writing it the way I did, okay? But if you feel comfortable writing it that way, that's fine, because you're going to type it in anyway. Now, in that concept of A plus BI, now this is the real part, the imaginary part. Okay, that's what this is all about. So when we see numbers, we just add them together. When we see the imaginary I thing, we put those together. So when we're looking at this, then we see 8 plus 22 is 30. We can add them in our heads. And then negative 14 added to 20 is 6. So we're going to get 6i. And there you go. There's our answer. All right. That's it. Look at that. I did that all mentally. Likewise, take 8. Now, here's the thing is that with the other part there, it's sometimes helpful for students to rewrite it like this. When there's a negative sign, go like this. All right. That is helpful for a lot of students to do it that way, because they distribute the negative sign to both things and make it become positive and default back to the rules of addition. Just add these together. Well, 8 added to negative 22 is going to give us negative 14. And then adding these two together, because they're both negatives, we're adding them together, we're going to get 34i. And that's our answer for that one. All right, and now we're going to move down. Oh, there's no more on that one. Okay, that's easy. Okay, that's a question. Thought they'd go through all of it, but they didn't. Now we have 51. Find the sum and difference of the same exact question. So again, when we look at these, we want to clean up those radicals first. So we get this. See, cleaning them up pretty quickly, we can go ahead and define it as this. All right. So we want to clean them up and then proceed to the addition thing. So negative 6 added to 3 gives us negative 3. And then we go ahead and add these together, we get negative 2i. All right, that's that part. And then we're going to get the same exact thing except for the next one, except we're going to get negative 6, and I'll put it over here. All right, negative 6, I'm going to squish it a little bit. Then we get plus, and then it's going to be negative 3, positive 5i. I kind of squished it in there, guys. Sorry. So negative 6 added to negative 3 gives us negative 9. And then we got 3 added to positive 5 gives us 8. All right. Always good to see the answer. Now for this one, question number 52. We're performing the multiplication of complex numbers. So when we multiply this times this, that gives us 24i. Now, whenever we multiply an I times an I, here's a note for that. I squared is equal to negative 1, by the way. I squared equals negative 1. So when we multiply this times this, that gives us negative 32. And we want to put it in the form of a plus bi, so we're going to write it as negative 32, positive 24i. And express the answer in terms of I. Okay, so there we have our answer. So the big deal there is this right here, this fact. You got to get that fact in your head. Okay. And the last and final one that we're going to do, I'll bring this, I'm going to use the bottom of this page. Okay, I'm sorry. I want to save a little bit of paper, I guess. Now, when we're performing this, and I'm going to erase this so this is out of the way. We have that. Let me do this. Because we're going to FOIL this, right? So that's the idea. So 2 times -10 is -20. Now 2 times -3 is -6i. And then -5 times -10 is +50 with the I. And then negative times a negative is positive. But remember, I squared is equal to -1. So when we multiply that out, okay, even though this is positive, you're going to get -15 because of the I squared. So I squared equals -1. Okay, remember that. Now, because then you can do it real quick, because the negative times the negative is positive, and I'll just switch it back to negative. All right, now when we bring this together, we get -35. We're bringing these two parts together, right? And then bringing these two parts together, we get positive 44i. Because we're going to subtract 6 from 50. And there's our answer. Gotta love getting it right. All right, now that covers all the questions within the focus questions. Okay, so that's what we just did. Okay, that comes from your posted announcement. All right, we covered all those. Now, good luck with your studies. Make sure that you're working hard, and you'll be successful on this next test. Thank you for listening, and I look forward to grading your work.